Our next presenter will be Melissa Taylor. Melissa is a program manager with the Law Enforcement Standards Office here at NIST, and she is the study director for the quantitative and qualitative terms working group that she's going to be discussing. Her work within the forensic science program focuses primarily on impression and pattern evidence-related research, improving forensic science management practices, and integrating human factors principles into forensic sciences. Her recent publications include the Biological Evidence Preservation Handbook, Latent Interoperability Transmission Specification, and Latent Print Examination and Human Factors, Improving the Practice Through a Systematic Approach. Ms. Taylor is a member of the American Society of Quality, the Interpol APHIS Expert Working Group, and the International Association of Identification. And she has previously served on the White House Subcommittee on the Forensic Sciences as co-chair for the Latent Print APHIS Interoperability Task Force. So please welcome Melissa.
Okay, so in the interest of time, I'm going to shorten the name of the working group to QQWIG. So when you hear that, that's what we're going to call it from here on. So what I'm going to talk to you a little bit about today is what the QQWIG is doing, who they are, and why they're doing it. Okay, so this is an 18-month project, and the purpose of the working group is really to identify ways for forensic examiners to best convey relevant qualitative and quantitative information, such as statistics, using verbal scales, expression of uncertainties, etc. The basic issue before the group is the presentation of statistics, not the production of the statistics. That's a very difficult distinction that we find ourselves making during the groups, is that everyone wants to talk about how the statistics are generated, what's the basis for the numbers that are used. But really we want to focus on, at the point where an examiner has some number or has a verbal scale, what's the best way to communicate that information to a layperson. Our hope is that the final document will provide information on how examiners can prevent confusion and really learn how to present information in a comprehensible way. So who are they? Well, the actual working group is a collaboration between the Law Enforcement Standards Office and Penn State University Forensic Science Program. The project is sponsored by NIJ, and the working group was selected, purposefully to be diverse. It's made up of forensic practitioners, legal scholars, psychologists, researchers, statisticians. We even have a retired federal judge on the working group. So here's a list of the members. We have Joanne Biscaglia, who's in the audience today. She sits as a member. Jerry Laporte is also a member of the working group. But you can see it's a diverse mix. We have federal practitioners. We have folks from all sorts of different universities and coming from different backgrounds. So the management team consists of 3 co-PIs from Penn State, David Kay, Cedric Newman, and Angeli Randive, who's actually a consultant, but she is working with Penn State on their management of the working group. And on the federal side, Jerry Laporte from NIJ and me from OLIS. Okay, so probabilistic statements and statistical arguments are ubiquitous today. We hear weather reports in the media, and across the last day and a half, we've heard this topic of big data, right? There's a trend toward individuals collecting lots of data and then summarizing it in some form. Unfortunately, the general population, may not be able to understand and use this information because studies show that half of the U.S. population can't do basic math skills. So, for example, they can't calculate the difference between the sales price and a regular price. They can't estimate the cost per ounce of an item in the grocery store. This is even when they're provided with a calculator. That's alarming, right? So if you think about all the statistics that we've heard this morning being presented to someone who can't calculate those basic arithmetic functions, you can be dangerous when you're using statistics. So take, for example, this scenario. It's actually a question that was used. let me just get the right title here. The National Weather Service wanted to really look at making their terminology consistent so that when someone heard the forecast that they would understand it correctly. So the question is, today the meteorologist says the chance of rain is 60%. You understand this to mean, A, rain will occur 60% of the day. B, at a specific point in the forecast area, for example, at your house, there is a 60% chance of rain occurring. C, there is a 60% chance that rain will occur somewhere in the forecast area during that day. Or D, 60% of the forecast area will receive rain and 40% will not. Anyone want to throw out an answer? C?
Take an umbrella.
Well, if you answered C, you are in the you are not in the 9% that answered this question correctly. The correct answer is B. So that goes to show you that, it's not as easy as it seems to present statistical information. So you may also be thinking that maybe if, it's hard to verbally communicate statistics, you can throw up a graph, right? That will help clarify any points. But I don't know if you guys have, looked at the graphs that we've heard here today, but I found myself tilting my head to the side to see if it would help me understand it a little bit better. It didn't work, but but you get the gist that not all visual representation of data simplify the topic. You might also be thinking that maybe this is a function of education, right? That people who have higher levels of education would have higher levels of numeracy, right? They'd be able to perform these functions better. But studies show that 16% of highly educated people have difficulty judging whether a 0.001 risk of death is bigger than 1 in 100. And those types of statistics and research are being conducted for health literacy, like trying to understand how best to communicate your risk of disease to people who have tests that show that they might have a potential. What is their understanding of their risk of that disease? So there's a lot of research in that area. So the working group is looking at a lot of this research, a large body of research that's in the decision sciences that focuses on evaluating the effects of numeracy. And numeracy can briefly be explained as the ability to access basic probabilities and numeric concepts. Just as literacy affects your ability to understand the written word, numeracy affects, is a judgment of your ability to assess numbers. Okay. Statistical numeracy has shown to be a predictor of decision strategies, emotional reactions, and accurate comprehension of data. So this statistic is really important to forensic scientists to understand how best to communicate so that the general population can understand the results of their data. So this is just a summary of some of the findings of the vast majority of numeracy research, that there's evidence that individual differences in numeracies affect judgment and decision making. Innumeracy is widespread, going back to that 50% of the U.S. population not being able to do simple math. Misunderstandings arise from non-transparent framing of the information. And there's limited research on which presentation formats are most beneficial for individuals at different levels of numeracy. Okay, so I figured that you guys are all wondering, well, how literate am I in numbers? So I decided to give you guys a little test, right? So just so that you can get a sense of what these tests are. And so the Berlin numeracy test provides a fast psychometrically sound is a psychometrically sound instrument for the assessment of statistical numeracy and risk literacy. I picked the test because it's short. It's usually between 3 and 4 questions. The test takes about 3 minutes. The instructions are, don't use a calculator, just use pen and paper. Over the last few weeks, I've tortured my oldest colleagues with a number of these tests to see whether or not they could do it. I even tested my 7-year-old stepdaughter, who hated me for the afternoon for having to explain what the right answers were. So when you guys are ready, we'll start. 1 minute per question.
We're just going to do one at a time?
One at a time. I actually made it easier for you guys than I did for the folks that I previously tested. I made it multiple choice. I know, right? All right. Question 1. Imagine we are throwing a 5-sided die 50 times. On average, out of these 50 throws, how many times would this 5-sided die show an odd number? 1, 3, or 5? Go.
Twenty seconds left.
No calculators.
Time.
Okay. Question 2. Out of 1,000 people in a small town, 500 are members of a choir. Out of these 500 members in the choir, 100 are men. Out of the 500 inhabitants that are not in the choir, 300 are men. What is the probability that a randomly drawn man is a member of the choir?
Seconds remaining. Time.
Okay, question 3. Imagine we are throwing a loaded die 6 times. The probability that the die shows a 6 is twice as high as the probability of each of the other numbers. On average, out of these 70 throws, about how many times would the die show the number 6?
Seconds. Time.
Okay, pens down. So you'll be happy to know that I didn't torture you. I put the correct answers in the presentation. Answer to number 1 is C. Answer to number 2 is B. Number 3 is A. So, what does that mean? If you scored... Don't all walk out of the room, right?
You might not have written down the letter.
Oh, you didn't write down the letter? Okay. So 1 was C, right? Yeah, 1 was C. 2 was B, which is 25%. And 3 is A. Okay? Everyone got that? All right, so if you had 0 correct or 1 correct, your numeracy score is similar to those in the bottom 25% of college-educated individuals. 2, your numeracy score is better than about 50 to 75% of all college-educated individuals, and your numeracy score is better than 75 to 100% of all college-educated individuals if you got all 3 right. If you want to take this test, they have longer versions of the test. You can go onto riskliteracy.org. It's actually a better format in the test. They don't do multiple choices. They score it automatically, and they have a different scheme for testing. So if you answer the first one wrong, you get 2 different questions than you would if you answered the first one right. So if you enjoy torturing yourself with these types of tests or want to torture others, you can check out that website. So needless to say that if you don't understand this type of information, you're going to find it very hard to communicate it to others, right? So we want to try to, with the final document, give people an understanding of what some of these principles are and gives them ways to explain them in a better fashion. So I'm going to turn back to the working group and give you some information about what we've discussed so far. As I've said, the working group is just beginning. We're about 6 months into the 18 months. So the working group has met twice, had several discussions, but don't really have a good sense of what their findings, their final recommendations are going to be. So I'm going to give you just in broad terms some of the things that we've discussed, some of the questions that we've still yet to answer, and then give you an idea of what the final report would look like if it was written today. So the QQWIG talked about various presentation approaches. So currently you have the choice of just presenting the data, so presenting 2 fingerprint images, presenting 2 handwriting samples, and have the juror or whoever you're communicating to make their own assessment. Then you can provide qualitative data, right? You can provide strength of evidence. You can talk about consistent with. And give other verbal scales. Then you can talk about your conclusions in terms of quantitative data, talking about the probability of match, using likelihood ratio, putting your answers in terms of posterior probabilities. And then we also talked about ways to testify about errors and the probability of errors, whether or not you could do it through proficiency tests, whether or not it's possible at all given the current data that we have. So these are just topic areas that we've discussed. Okay. Some questions that are left for us to tackle. When should probabilities be used, and how should they be stated or characterized? Are verbal scales really better than giving a number? Sometimes people prefer to get a verbal scale rather than a specific number, and specific numbers connotate a certain level of certainty that may not be there in the numbers that are provided. So we want to better understand when is it best to use either approach. Can these verbal scales be standardized across different forensic disciplines? Could there be one scale that you use for all forensic disciplines, or would that be too difficult? How best to map likelihood ratios to verbal scales, whether or not you could do that in both orders, meaning you select a number and then map it to a verbal scale, and do it backwards where you have an item on a verbal scale and you automatically map it to some number. Is there a difference in those 2 approaches, and whether or not they're recommendable? And then finally, what type of visual aids or illustrations or analogies, if any, would be helpful, right? Sometimes analogies can be helpful. Other times it causes additional confusion. It's just like adding a graph, and expecting people to understand the graph. So we want to really think through whether or not analogies would be appropriate, and then also hopefully provide some that could be used by the community. Okay, so if the report was written today, we start off with our standard introduction, that will really discuss what our methodologies were, what research we went to, and how we went about doing our work. The Chapter 2 will provide examples of testimony and reporting, right? So it's really just a summary of current practice to date. And this, let me back up. What I didn't say is that this working group is not just focusing on handwriting analysis. We're focusing on the presentation of all forensic conclusions. So the 3rd chapter is going to talk about the psychology of effective communication, and that chapter is going to really focus again on how people understand numbers and the words that may be used to describe them. We're going to focus on discussing what that people have difficulty with numeracy, ratios, fractions, the tyranny of large numbers, and so on. Chapter 4 is really going to discuss the nature of forensic inference. We heard this morning about how forensic inference can be investigative or evaluative. We'll be discussing that in great detail. Chapter 5 will be on how to present quantitative and qualitative data. This chapter will provide best practices on how the data can be presented. And then Chapter 6 will focus on how to implement the recommendations and also tackle areas where additional research is needed. Because we're not going to be relying on research that's done in the forensic domain, because there doesn't seem to be a lot of research out there specifically, but there's a lot of research out there in other domains that we can glean some information from. So I just wanted to take this opportunity, since I'm here, to give you a heads up on another project that we should be kicking off in the fall, which is the Expert Working Group on Human Factors and Handwriting Analysis. This will actually be the second working group in a series of working groups that look at what the effects of human factors are on forensic practices. The first report was in latent prints. It's out if you want to take a look at what the results of that working group are. I think it's a great document. It discusses error rates. It gives you a good idea of what common practices are, issues with interpretation, issues with testimony. It also goes into management issues. How does culture impact performance? So it's a good document. You can find it at nist.gov/OLIS. That project was also supported by NIJ, as will the handwriting analysis project. So stay tuned. This report will probably be out in the first quarter of 2014, and it'll be on the NIST OLIS website as well. Thank you.
Any questions for Melissa?
Not after I gave you that test.
Nothing online.
Okay.
All right. Thank
Thank
you,
you.
Melissa.
Can we put that on?